So this video is on solving absolute value equations. So we're going to review what is an absolute value. So an absolute value is a number's distance from zero. Numbers. And the important part about it, well, I guess a number's distance from zero. All right, it's always positive or zero. Because distance is always, I didn't move or I moved a positive number of units. So I might have moved a positive number of units in the negative direction. All right, but it's still a positive number. All right, so let's look at this. So if we have x equals the absolute value of x equals 7, let's think of two numbers that have an absolute value of 7. So that could be 7 has an absolute value of 7, or negative 7 also has an absolute value of 7. So generally, when it comes to absolute value equations, you're going to have two solutions. One for the expression inside the absolute value to equal positive, and then what's in that absolute value, that expression can also equal a negative number. All right, so you're going to have two solutions. What else is important is think about what numbers would have an absolute value of negative 7. None. All right, so if I had an equation that looked like this, I would say it had no solution. All right, because no absolute value can equal negative 7, or we can write it like that, no solution. So to solve an absolute value equation, first thing, if your absolute value isn't by itself, you need to get it by itself. Once it is, we're going to look at it and say, all right, does it equal a positive? Okay, so let's split our equation in two. Once where it equals a positive and once where it equals a negative, and solve those to get our solutions. If that equals a negative, then we're going to say, hey, this doesn't have a solution, and we're going to move on. All right, so let's look at some examples. Let's write some examples down. So let's do this. Example 1. So let's say absolute value of 2x plus 5 equals 13. All right, so the absolute value is already by itself, meaning there's nothing outside that absolute value. Unlike example 2 that we'll do, that looks like this. See how the absolute value is part of a bigger expression? When we go to do that one, we're going to have to get that absolute value by itself first. This one, example 1, the absolute value is already by itself. So it equals a positive, so I know there's going to be two solutions. So 2x plus 5, that expression can equal 13, or that expression could equal negative 13, and it would still, the absolute value of it would still equal positive 13. So this can be positive or negative and still work in the equation. I would still get a true solution. So I wrote the two equations without absolute values. So the first equation is going to equal the positive, second equation is going to equal negative, and I'm going to solve. I'm going to subtract 5. I get 2x equals 13 minus 5 is 8. Divide by 2. X can equal 4. Here I'm going to subtract 5. 2x equals negative 18. Divide by 2. X equals negative 9. So this has two solutions, negative 9 or 4. And sometimes you'll see it written like this in set notation. Okay, sometimes you'll see it written like that. So negative 9 is a solution and 4 is a solution. When I substitute 4 in there, I get 8 plus 5, which is 13. And the absolute value 13 is 13. When I substitute negative 9 back into the equation, I get negative 18 plus 5, which is negative Negative 18 plus 5 is negative 13, and the absolute value of that is 13. Okay. Sometimes you have examples like number 2, where the absolute value isn't by itself. And we have to get it by itself. Here's a warning. You cannot distribute across an absolute value. So I can't do 2 times both of those things. All right, I can't do it. So that's a fair warning. It's a common mistake people make when solving absolute value equations. You'll see them distribute. You can't. Distribution only works with parentheses. So I'm going to get that absolute value by itself by getting rid of the addition first, just like we would do in an equation, a regular equation, because this is an equation. So now I have absolute value of 2 times the absolute value of 2x minus 7. These 11s cancel out. 25 minus 11 is 24. Now, because I can't distribute that 2, and that means 2 times that absolute value, I can do the opposite. Nope, this should be 14. I'm looking at that, I'm like, 25 minus 11 is 24. It's 14. Okay, so I got to get rid of that 2 times the absolute value. So I'm going to do that by dividing. So now that 2 goes away. I have the absolute value of 2x minus 7 equals 14 divided by 2 is 7. I look at that and I say, all right, that absolute value does equal a positive. So there will be a solution to this. There'll be 2. So I'm going to say, all right, 2x minus 7 can equal 7. 2x minus 7 could also equal negative 7. And I'm going to solve these 2 equations and get my 2 solutions. Add 7. 2x equals 14. Divide by 2. One of my solutions is 7. This should be negative 7. I forgot to make this a negative. So make sure we're clear on that. I was like, that's the same equation. All right. Add 7. I get 2x equals 0. Divide by 2. My other solution is 0. So 7 is the solution and 0 is the solution. So those are my 2 solutions. Again, sometimes you'll see that written like so. Get the absolute value by itself. See if it equals a positive or a negative or a 0, and then set up your equation. If it's positive, if you get a negative, there'll be no solution. All right, so let's do a couple more examples. So we're going to do example 3, which is negative absolute value of x minus 2 equals 5. And then example 4 will be the absolute value of 5x minus 3 minus 4 equals negative 4. Okay, so let's do these 2 examples. All right, so let's look at example 3. There's a negative outside of here, and I need to get rid of that. We're going to treat it like a negative 1. So if I divide both sides by a negative 1, it'll get rid of that negative. So x minus 2 is going to equal negative 5. 5 divided by negative 1 is negative 5. So again, I treat that kind of like a negative 1 there. Divide both sides by negative 1. And then now the absolute value is by itself. But I have the absolute value of x minus 2 equals negative 5. An absolute value can't equal negative. So this has no solution. Which if you want, you can use that symbol. That means null set, meaning there's no solution. Sometimes it's written like this too. For the 2 braces with nothing inside of it. Okay, so sometimes it's written that way as well. Okay? So I got the absolute value by itself, no solution. All right, so let's look at number 4. So we have the absolute value of 5x minus 3 minus 4 equals negative 4. we have this equaling a negative number, but the absolute value isn't by itself. So we don't know if there's a solution yet. So to get rid of a minus 4, I add it. Notice the difference between 3 and 4. Number 3 was negative times that absolute value. Here I have a minus 4. So I have a subtraction of 4. So to get rid of it, I add a 4. I get the absolute value of 5x minus 3 equals 0, which an absolute value can be 0. That's a perfectly acceptable. But you wouldn't put positive 0 or negative 0 because 0 is just 0. There's only one number that has an absolute value of 0. So I'm only going to have one solution. So I just solved that equation. I'm going to add 3. I get 5x equals 3. Divide by 5. And I get x is 3/5. Right, that's the one solution that works in this equation because there's only one number that has an absolute value of 0. All right, so absolute value equations, you're going to get the absolute value by itself. Once it is, does it equal a negative? No solution. Does it equal a positive? All right, write your expression equals a positive. Your expression should equal a negative, and you solve those two equations for your two solutions. Does it equal 0? Well, we only need one equation, and we're going to solve that one and get a solution.